Hey everyone. Last time we were talking about sets, and this time we're going to be talking about a related thing, maps. Now, maps are not too hard. Last time we talked about sets being a collection of things, and all maps are a way of relating to sets. So if I have a set 1, 2, 3, I can relate them. I could relate it to the set 4, 5, 6 by either kind of just drawing arrows, or in fact I could write down a rule. I could say that f of x goes to x plus 3. Now here f is called the map because it relates two sets, and then we write a colon and we write where it's starting, which I'm going to call A. So this is going to be the set A. This will be set B, and A goes to B. So F just relates things in A to things in B. A is called the domain, and B is called the codomain. So to give you another example, we could have a map called G that goes from the integers, which we call Z, to integers, we call Z, and this means it eats some integer and gives us back, say, an integer squared. Now, it's important to note that there is a separate thing called the range. And the idea of the range is that sometimes we might not use up everything in the codomain. So we might have a function, and if we have, and this function might go from the set 1, 2, 3 to the set 7, 8, 9. And we might say 1 goes to 7, 2 also goes to 7, and then 3 goes to 9. The number 8 here is in the codomain by definition, but it's not in the range. So we call the range the set of reachable output values. Forgot to spell output there. So maybe to give one last example, if I define the function h from the real numbers to the real numbers, and I define it as h of x equals x to the 4. Now, -1 lives in the real numbers, so it is in the codomain. But -1 is not in the range of h because no number, when you cube it, gives you -1. Now, there are two important types of maps we need to know about. The first one are injective maps. And these also are called one-to-one maps. This just means every input goes to a different output. So to give an example of an injective map, let's say I define f123 goes to 4, 5, 6, and f of 1 goes to 4, f of 2 goes to 5, and f of 3 goes to 6. This is injective because all three are different inputs go to a different output. To give an example that isn't injective, well, we could simply have changed this from sending 3 to 6 to send 3 to 5. This means that if we at 5, we don't know which input got us here. Could have been 2, could have been 3. And because of this, we also can't undo injective maps. They don't have a nice inverse if that's not injective. The other type of map we want to talk about are surjective maps. And these are maps where the range is the codomain, which in more normal language just means we can reach every possible output. So the function f from the real numbers to the real numbers, that is f of x is x plus 2, is surjective. I can reach any possible output with the correct input. But the function g, which is, say, g of x is x cubed, sorry, x squared even, is not surjective. And this is because -1 is in R, but is not in the range. Now, there's a special kind of map called a bijective map. And this just means it's both injective and surjective. Now, the final thing I want to talk about is this idea that we can have functions that take inputs. Specifically, I want to look at functions that take 2 inputs. So let's say I have 3 sets. 1, 2, 3, 4, 5, 6, and call 7, call C, 7, 8, 9. I can define a function that takes an input from A, an input from B, and sends it to something in C. And I might define it so 1, 4 is 7, f of 1, 5 is 8, f of 1, 6 is 9, and so on. And to give maybe another example, I could even have these sets be the same. So I could define a function from the real numbers to the real, from 2 real numbers to another real number. So f of xy is equal to x plus y minus 2. And to see what this is like, we can see an example. I can put in 4, 3, then I'd get 4 plus 3 minus 2, which, if I can do mental maths correctly, is 5. Now, we could do this for any number of inputs, but really, binary operations are maps that take in two inputs. And we're going to use them a lot going forward. But that is all for today. Thank you for listening. See you next time.